Hello, this is Gregory Carlson, and welcome to 2.6 Part 2. Um, the next question says, choose the graph for the following piecewise function. So you can see we've got this graph here. The cutoff is at 2, and so if we're less than or equal to 2, the graph is going to be of the form 1/5 x squared plus 3. So if we're smaller than or equal to 2, we're going to be this quadratic graph. If we're bigger than 2, then that means we're a linear graph. It's a line. It's 1/5 x. You can see that that's a line with a slope of 1/5 that's going to go through the origin. So the question is, which one of these four is that? And here's where it really helps to know what your parent functions look like. Because if you know what your parent functions look like, then this is going to be really easy. So for example, I know that this is a positive line, so that means this is a line that's going to be going up as we go from left to right. I know what a parabola looks like. A parabola looks like a U, kind of looks like a U, and so this is going to be a parabola with an intercept of 3, and it's positive, so it's going to be opening up. So when I look at that, let's just think about the parabola. It's a positive parabola, which is a positive U, and we can see that here I've got a negative U, so that's going to be wrong. And here I've got a negative U, so that's going to be wrong. So it's either going to be B or C because the left part of the graph, when we're less than or equal to 2, is going to be this positive upward U right here. Now, is it going to be going down like this on the right side or up like this? And I know that's hard to see, but maybe you can see it better on your paper. So let's think about what this line is. This line is 1/5 x, and so that means for x is bigger than 2, that's a line with positive slope, positive 1/5. So starting here, we're a line with a positive slope, and so that means this should be our answer. It's not a negative line, it's a positive line. So you can see that I figured that out without even graphing any of these, just by knowing in my mind what the parent functions look like, which was the end of 2.5, part 3. um, you can quickly find this answer. But let's say you forgot all of that and you can't remember how to do this, then simply remember that you can graph points. Plug in some values for x. And if you do enough of those, you'll see connect the dots and you'll see what the graph should look like. And then you can match it to the answer that you need. So let's do another example of that. Choose the graph from the following piecewise functions. We can see that on this piecewise function, we have two breaks. We have a break at 0 and we have a break at 1. So when we are in between -2 and 0, we're going to be this graph. When we're between 0 and 1, we're this graph. And when we're between 1 and 4, we're this graph. So let's try to use process of elimination to figure this out. So where would I start with this? I'd probably start with this third piece because we know what a negative quadratic is supposed to look like. Hopefully you know that an x squared is a positive u that looks like this, but if it's negative x squared, it's going to be a negative u. And so as we go from 1 to 4, as we're on the right side of the graph, we should be doing a negative u. So you can see that that immediately eliminates answer choice A. It looks like B, C, and D all have that negative rightward u, so they're all still in the running. So, okay, so we've used this information. Let's use this middle information. If we're between 0 and 1, then we should be y equals the positive line x plus 2. So that's a positive slope going through the intercept of 2. So that to me looks like in this middle section we have a positive slope. That looks like we have a positive slope. But if you look very carefully, I think that's a negative slope right there. So we can eliminate answer choice D. All right, so our only real choice is the graph looks the same. The only real choice now is it looks like it's starting down going up or starting up going down. And so let's think about this graph right here, y equals negative x to the third plus 2. You should remember from your parent functions that this is what y equals x to the third looks like. This right here is kind of what y equals x to the third looks like. But notice that's y equals positive x to the third. Y equals negative x to the third looks like this. Do you see how it kind of flips it? It flips it up and down. And so this is the graph that we're going to be looking like because of this negative x to the third right here. And I know we haven't gone through all of these parent functions yet, but we will in class. So you can see that if we're negative x to the third, as we go to the left, our graph should be coming up, which means that the answer to this question is going to be answer choice C, and we can eliminate answer choice B. That's kind of tricky to do at first, but you will get the hang of it. So let's push forward. Here's another example of a piecewise function, and it says that this is the time and gallons of water in a pool. So maybe this is during a really hot day, and so there was evaporation. Maybe this is, I'm not sure, maybe this is time when they were not necessarily adding water because the level in the pool is remaining constant. So let's take a look at it. For the graph above, estimate the initial and final amounts of water in the pool. So let's see, this axis over here is going up by 4 every time. And so if I look, it looks like the starting value of the water, because remember we're starting at 0, looks to me that that's the value of 50 right there, halfway between 48 and 52. So I would say that the initial water is 50. And let's say the final level in the pool will be right here. If I just follow this along, that to me looks like it's in between 28 and 32. So the final amount of water is going to be 30. And this is in thousands of gallons. So it'll be 50,000 we started at and 30,000 we finished at. When did the amount of water in the pool remain constant? Notice they're talking about when, which means we're looking at x. So it looks like we remained constant here, and we remained constant here. So let's put this in interval notation. We remained constant from 0 to 1, or from day 0 to day 1, and we remained constant from day 3 to day 4. So we should put the or symbol because we were constant there or there. If I had said and, that means it needed to be both. But since it was constant here or here, we put the or symbol. Please approximate f of 2 and f of 4. Well, f of 2 means we're going to plug in 2 into the function and try to estimate what the value is. So plug in 2, and I think I'm that point right there. And you can look closely at your paper. When I come across, it appears to me that that value right over here is 42. So I would say f of 2 is equal to 42,000 gallons. If the answer choice says in thousands, then you only need to put in 42 right there. Let's calculate f of 4. So if I plug in 4, I hit this line right here, and when I come across, it looks like that's equal to 36,000. Just like that. So that's how you would evaluate f of 2 and f of 4 as they give them to you. At what rate was water being drained from the pool when x was between 1 and 3? So let's look at that. From x going from 1 to 3, we see that we were falling. And so what we should actually do is use the slope formula here to figure this out. So remember, we're trying to find the slope, which will be y2 minus y1 divided by x2 minus x1. So this first point right here is the point 2, 50. And this point right here is 3, 36. And so if we find the slope between these 2 points, that means we're finding the rate that it was draining. So our points again were 250 and 336. So let's plug those into the formula. Whenever they're asking you about a rate, what rate is something on a graph, you should think slope formula, because that's the change in y over the change in x. For the x's, we do 2 minus 3. So simplify that. 36 minus 50 is negative 14. Divided by 2 minus 3. Oops, I got that backwards, didn't I? 36 minus 50, that should have been 3 minus 2. Sorry about that. It's important to get this right because that way our sign will be correct. So that should have been 3 minus 2 because it was 36 minus 50 and 3 minus 2. So we got 36 minus 50, 3 minus 2 is 1. So that means we can see that in one day we fell 14,000 gallons. So it's a 14,000 gallon decrease per day. So that negative sign means it's a decrease. It's a decrease of 14. And our graph says that these numbers are in thousands. So that means it's a decrease of 14,000 gallons per day. Notice there was a 1 right here, so it was per day. If it was a 2 right here, say, then you'd do 14 divided by 2, which would just be 7,000. So it'd be 7,000 decrease per day. But because it was just a 1 here, we were good to go. So that is College Algebra section 2.6. We are actually done with that section now. So I will see you in 2.7.